All right, let's go ahead and get started. Welcome everyone, and thank you for joining us today on this 3D Slicer 510 webinar. We're very excited to share the latest features, improvements, and new capabilities in this major release. I am Andinet Enquobahrie. I'm a senior director here at Kitware. I'm joined today by my colleagues Ebrahim, and Sam Horvath. All of them are part of the Kitware's team that is contributing to 3D Slicer's core development. Over the next hour, we'll walk you through what's new in version 5.10, this which includes upgrades to Python, core dependencies. We've got improvements in volume rendering, segmentation workflows. There are new core modules and also new extensions from the community. We have also scheduled a live demonstration so you can see these features in action. So we definitely encourage you to submit questions throughout the presentation using the Q&A panel. We also reserve time at the end for an extended Q&A session. So any questions that we haven't gotten to, we'll be able to address them at the end. So with that, let's get started. Before we dive into the 5.10 release, I just want to take a quick moment to introduce Kitware for those who may be new to our work. We are leaders of open source software development, founded in 1998. Actually, the same year 3D Slicer was born. We are headquartered in upstate New York, Clifton Park, New York, with 6 offices across the United States and Europe. And then we are a proud 100% employee-owned company. We have about 200 employees right now. What makes us unique in the industry is our deep commitment to open source, open science, and open data. Besides 3D Slicer, which is the main focus of today's webinar, we develop and maintain some of the most widely used open source software. You have VTK for visualization, ITK for image analysis, CMake is a cross-platform build system, ParaView for scientific visualization, and then Pulse for physiological simulation. Using these tools, we work on a lot of areas which span from medical image R&D, computer vision and AI, scientific computing, and custom software development. We also provide FDA regulatory support for medical device companies that are interested in developing products around 3D Slicer. So our contribution and involvement in 3D Slicer dates back to 2004 when we joined the NAMIC consortium. This was the National Alliance for Medical Image Computing. This was a big NIH-funded initiative where it brought together leading institutions in the research community to build NAMIC kit, where 3D Slicer was the main one. And since then, there were a lot of key milestones with Slicer's 3 release in 2007, the development of the common toolkit. This is a common UI library that's used by 3D Slicer and other medical image applications. In 2011, that's when actually the major re-engineering effort happened with Slicer 4, where Kitware played a major role. Besides, obviously, contributing to core development, we help translate the platform into commercial products for our commercial customers. And this includes FDA approved applications. And we do have other custom applications like Slicer Salt for shape analysis, Slicer Cat, that's for custom development of application, and also Slicer VR for virtual reality. So we're very excited. We're very happy about our commitment. We've contributed more than 10,000 commits to Slicer, and we maintain all the critical infrastructure that are needed to keep Slicer going, including extension infrastructure and a lot of the Slicer core and extension continued integration testing. All right, so we will, in today's webinar, what we'll do is we'll start with a quick overview of 3D Slicer. So I know there will be folks in the audience that are new to 3D Slicer. So we just want to spend a little bit of time talking about what's 3D Slicer, what's its impact, and also what are the primary use cases for 3D Slicer. And then Ebrahim will take over and he'll give a demo of all the critical new features in Slicer 510. And then Sam will take over and she'll go over some of the key highlights in Slicer 510. This will include some new features, some new extension modules we have. And then we will be looking forward to Slicer 6.0. We will talk about some of the things that are planned in Slicer 6.0. And then at the end, we'll have a Q&A session where you'll be able to ask questions. All right. So before we get started, just want to take a quick poll question here. We'd love to hear from you, so we kind of get a sense of who is in attendance today. So the poll question is, how familiar are you with using 3D Slicer? And we're providing you 5 choices: total beginner, with some experience, intermediate user, advanced user, and then expert developer. So please take a moment to respond to this poll question. All right. So yeah, thank you for responding. So we have the majority being with some slicer experience, which is excellent because we'll be talking about new features in 510 and also total beginners. So that's great as well because we'll cover about what's slicer, what's impact, and how you can use slicer in your research and product development. So, why is 3D Slicer have become one of the most popular medical image analysis and visualization application? Obviously, it's because it's open source, freely available, so you don't have to pay any license fee, and it can be used by the research community to build a lot of cutting-edge technologies. And also, 3D Slicer is very popular among medical device companies and commercial companies because you can build a proprietary application on top of 3D Slicer because of its permissive BACD style license. It's very customizable, so you can use it for cancer research, you can use it for surgical data science, and you can use it also for image-guided surgery. So there are a lot of modules available. It's extendable. It can be customized and expanded. Also, it's heavily dependent on open source libraries under the hood, like ITK, VTK, and CMake, which makes it a lot easier for doing reproducible science. So you'll be able to generate results and share it with your colleagues, and they will be able to reproduce the results that you've got. What are the key capabilities? Obviously, the big one is being able to handle medical image data, DICOM support. You could do visualization, both 2D and 3D. And then if you're looking at isolating some anatomical structures from your medical image data, Slicer has a whole slew of different segmentation methodologies, from basic classical techniques all the way to advanced AI-based segmentation algorithms. And also, you can also align images from different modalities and time points using registration modules. After you do segmentation registration, looking at doing some quantification, for example, measuring volumes, distances, and other image-based metrics, and 3D Slicer provide several modules. And also, folks who are interested in robotic-assisted surgery or interventional workflow, 3D Slicer has several modules that are well suited for building a real-time guidance application. All right. Well, just to show the impact, I mean, these are some of the stats that we recently developed. Since its release in 1998, there are more than 1.95 million downloads in 3D Slicer, and it continues to have a high citation in papers and publications. Also, the most exciting part, more than 190 extensions have been developed and contributed by the ecosystem. And these extensions have been downloaded more than 8 million times. Well, another thing we look at the impact is how the numbers of the paper slicer main paper citation in the community, and as you see, there's an increased citation of 3D slicer in publications. All right, so before we dive into the 5.10 release details, I want to just quickly go over what are the three primary use cases for 3D slicer. 3D Slicer can be used as a radiological workstation. It has, high performance visualization, analysis, modules and functionalities, and that can be used for clinical research. Also, as most of you in the audience are working on building new modules, new algorithms, it can be used as a research software platform because it has a very flexible programming environment and Python interface or C++. So you'll be able to quickly develop and test new quantitative methods. And the third one, which is continue to grow, is it can be used as a product development platform. So if you have an idea that you wanna develop and bring into the market, you can use 3D Slicer to rapidly prototype, iterate, and deliver solutions to end users. And we, as a product development platform here, I'm just showing some use cases where 3D Slicer has been used for prototyping and customizing applications for clinical and preclinical domains. All right. With that, I will hand it over to Sam.
Yep. So before we dive into the specific features of 5.10, we're going to kind of look at the top level numbers of the scope of the release, because this has been a substantial update kind of effort-wise for the 3D Slicer community. On the contribution side, we've merged over 200 pull requests, fixing more than 100 bugs, adding features, maintaining dependencies. This represents a tremendous amount of work from the Slicer community and the core developer team, which includes 3D Slicer and our friends at Queen's University, Brigham and Women's Hospital. This is an ongoing effort between multiple research teams to keep this project alive and running. So the extension ecosystem continues to expand. We've added 18 new extensions for this release, bringing the total to over 190. These extensions range the gamut from adding additional image input and output formats to adding cardiac imaging, surgical planning, and of course a significant amount of new AI features, because that has become a huge accelerator for adding new functionality to 3D Slicer. For core modules, we've essentially promoted one very useful extension module, the line profile, to a core module to improve its supports and so that we can have better utility for that functionality. On the infrastructure side, we have been mainly focusing on updates. For example, we have updated the Python version, the VTK versions, and kept up with the main branch of ITK. These updates bring performance improvements, new features, and improve the overall, modernity of the software. These improvements are across the entire platform: I/O, scripting, API, visualization, and so all across the entire experience of 3D Slicer, we feel that we've made big step forwards in usability and stability of the software. Some of the notable new extensions that we've included are the Andinet Interactive for segmentation, and Multiverse for AI-powered segmentation, Slicer Ants Pi for a new interface to the Ants registration modules, OpenLIFU for focused ultrasound research, SpectRecon for nuclear imaging, and 5.10 has been updated to run on the latest versions of the three main platforms, Windows, macOS, Linux, with forward-looking capabilities for CMake 4 and Visual Studio 2026 support.
Yep. Sam, a question came in.
Yep.
So the new the extension modules, do they get built across all the different platforms?
Yes. So the extensions, there are some like narrow exceptions where the extension is wrapping some library or piece of hardware that only exists for one platform. But outside of those, where the extension itself is, you know, platform limited, for every release and for every nightly release for our CI builds, every extension is built, packaged, and distributed. So when you download a nightly version of Slicer, you get the most recent versions of all the extensions. I guess the one kind of caveat there is that when you're doing the nightlies, it does take a little bit of time for those extensions to come in. And so if you're waiting, right off the hook to get the new extensions first thing in the morning, you may want to, have a snack first and give it some time.
Okay, thank you.
Yeah. So the key highlights, we'll give you a quick preview that we'll be covering in the demos that Ebrahim is going to walk us through. That includes volume rendering improvements, big improvements to the transfer functions for doing volume rendering, which is the most important and sometimes the least fun of getting your nice visualizations set up. We've improved scene views, which are essentially visual bookmarks to help you set up a specific visualization and then get back to those visualizations when you want to. These have been completely re-engineered and now work with the modern 3D Slicer infrastructure. We've added DICOM TLS support is a significant addition for clinical and enterprise environments. The DICOM listener now supports TLS authentication, which is essentially HTTPS, but for medical imaging data. This supports secure communication with hospital PACS systems, which require encrypted connections. And as more and more data security plans require encryption, this is a huge step forward to making the system usable in a clinical context. We've also made several segmentation workflow improvements, including segment visibility toggles, better terminology handling, and these quality of life improvements reduce friction in what is really our most used interface, the segmentation editor. We've completed and really solidified our Python 3.12 update. This ended up being a very significant updates for the underlying infrastructure of just even building our the Python version that we distribute with Slicer. And so now we are using modern packages, and it's a lot more user-friendly for those who install packages on their own. As mentioned before, new features and models such as line profiles and scene views, and the new extensions that we discussed in the stats review, and we'll be looking at more in the demos. All right, so coming up to poll question 2. So which feature of Slicer 5.10 interests you the most? So if you go ahead and kind of give us some idea of kind of what people are interested in and what they really want to hear about.
Yeah, and just as a reminder, the choices are volume rendering improvements, DICOM enhancement, segmentation workflow updates, some of the new core modules we have, and then the new extension modules. Right.
Okay.
So Sam, can you tell us what the results are?
Yeah, so looking at the results, the highest interest, 67%, is the segmentation workflow updates. After that, it's the volume rendering improvements, the new extension modules, and then DICOM enhancements and the new core modules. So yeah, everyone's always interested in improving the segmentation workflow.
Yeah.
Yep. Alrighty. And next, we'll jump over to Ebrahim for our demos for the new features.
Thanks. All right, so yeah, I will showcase some of the new features in Slicer 5.10. I'll go over some of the core features, and then I will go over some of the extensions, which are a select few of the many that are there. So I'll start with volume rendering. And sometimes you want to be able to adjust your volume rendering set without having to fiddle with plots. And the 3D volume rendering transfer function is now much more convenient to adjust. So let's load a single sample volume to start with. And I'll right click here to show it as a volume rendering. If I go to the volume rendering settings, then if I really want fully fine-grained control over the color transfer function and opacity transfer function, then I need to fiddle with these plots here. But sometimes, like in a radiological viewer, all you want to do is shift or scale these plots. And now you can use this tool up here to do that. You just click and drag on the volume. And if you move the mouse up and down versus left or right, you're shifting or scaling. You're changing the window or the level. And so you can do this just directly in the 3D view. And if I go and download another sample data, the CT chest, and show that in the 3D view as well, then when I click the MR head and drag, it changes the volume rendering settings for that. When I click the CT chest and drag, it changes the volume rendering settings for that. The next thing I'll show is the line profile module, which got added to Core Slicer. And this allows you to plot the intensity of a scalar volume along a line or curve. And this is useful for characterizing transitions between tissue types, or characterizing lesions, or doing stenosis assessment across a vessel, things like that. So let me clear the scene here, and then let's load a fresh MR head. And then let's go to the line profile module. So you select your input volume, create a new line. So it's just a markup. You can also create a curve, but here I've created a line. And then you say compute intensity profile. And actually I need a layout like this. Then you see it generates a plot of the intensity along the line. If I change the line around, then I have to click this again to get the intensity plot to update, or I can check this box to make it watch the line for changes, then you can see it change. That's the line profile module. Then the next core feature is 5D NRRD or NERD file reading and writing. So the NERD file is like a general array storage format. So if you have like a scalar volume, you could store that as a 3D NERD file. A 4D NERD file could represent a vector volume or a sequence of scalar volumes, or a 3D grid transform where one of the fourth dimension represents where you would put in the coordinates for the grid transform. And now in Slicer 5.10, it's possible to read and write 5D NERD files. So those could represent like a sequence of vector volumes or a sequence of grid transforms. And here I'm going to show you an example where I load a 5D NERD file that represents a sequence of grid transforms. So let me clear my scene here, set my layout, and then load in this CT perfusion imaging scene. This is an animation, so it's a sequence of scalar volumes, and you can see it playing and the hearts moving around. And the reason I started with this sequence of scalar volumes is because I was able to use the sequence registration module to register all of the frames to the middle frame. And that generated a sequence of grid transforms, which I then saved to a 5D nerd file. So that's here. It's called sequence of transforms.nerd. And what I'll do now is convince you that it is a 5D nerd file. So let me open a terminal here, and then this command is running a nerd file inspector on this file and showing you, okay, it's 5D. This is the shape of the array that's stored. The first dimension is the grid transform dimension that represents the coordinates, and then these three are the spatial, and then the sequence dimension, because it's a sequence of grid transforms. And then if I go to Slicer and I drag and drop this, you'll see it pop up in the list down here. There it is. And we can visualize it. So if I go to the transforms module, edit the display settings, say I want it to be visible and it's associated with a particular volume region, let's view it as a grid. Then I can play it back, and you can see the sequence of grid transforms. This is a 5D information that was read in. All right. Let me clear things here. The next one is scene views. So if you have a complex anatomical scene, then you often spend a lot of time setting up the perfect camera position and the perfect visibility settings and display node settings to highlight the different structures of interest. And so scene views and Slicer are like visual bookmarks that let you save and restore those states. And in Slicer 5.10, the scene views have been re-engineered such that they actually work and you can actually use them. And so in that sense, they're a new feature of Slicer 5.10. So let me show how that works. Let's load an MR head. To make it interesting, let's show it in the 3D view. And then let me save a scene view. So the scene view controls are these tools up here. And I'll go ahead and save a scene view. Let's call it my view 1. And I'll choose to capture all display nodes and all view nodes. I'll explain in a moment what that means. So I've now captured a scene view. I can now change things around. Let's say I rotate this, I change the slice selections here. I can even mess with the volume rendering settings. And then let's save another one, my view 2. We'll capture display and view nodes. And then for fun, let's do another one. Let's just rotate this, move this. Oh, that's a screenshot. My view 3. Capture display and view nodes. And now from here, I can restore the views. So this is a handy dropdown to do it from, but I like the scene views module itself where you can manage them. And so here, when I click the screen arrow, it restores each view. And you can see it's restoring the slice selection and the camera positions, but also the display settings, like the transfer functions that determine how the volume is rendered.
Yep. Ebrahim, a question came in. So if if they want to, they're asking if they want to only capture the 3D view, not the other layouts. Is that possible? Can you show if that's possible?
Yes. That's a great question. And when you save a scene view in the advanced controls, you can actually specifically say exactly which nodes you want to capture. So you would have to figure out what are the display or view nodes that are associated with the 3D view, which isn't too hard. I think this view 1 is the 3D view as opposed to red, green, yellow or the slice views. Then you can get very fine-grained control over what to save in the scene views. And yeah, that's a great question. And as for display and view nodes, these are kind of like shortcuts to select certain subsets of nodes. What's meant by view nodes is things like the camera positions and the slice selections. So think when you see view nodes, think like the actual view itself, settings of the view, as opposed to display nodes, which refers to how the objects are displayed. So like the transfer function for the volume, or even these are display node settings. All right. Then the next core feature is multi-component volume rendering. So normally in 3D Slicer, if you load a 3-component volume, like a vector volume with 3 components, then it will be interpreted as RGB. So 3 components will be interpreted as red, green, and blue. And the volume rendering will show up that way. Sometimes you need to control the color and opacity transfer functions of each component separately. So say, for example, you have 3D Doppler ultrasound, where one component represents the B mode intensity, which you maybe want to show in grayscale, and other components represent velocities, which you might want to color code in a certain way. It's no good if you load that in and it just interprets it as RGB. So now in Slicer 510, you actually can control the independent components. So I'll show you what that looks like with an artificial example. Here I have just a Python snippet that I'm going to copy into Slicer that creates a vector volume with 3 balls, and each ball is concentrated in one component of the 3 components. So let me clear my scene here, and then I'll paste the Python snippet that I just copied. And we'll look at the vector volume. You see it's interpreted as RGB. Let's enable volume rendering. And then let's go to the volume rendering settings. You can see it's set to RGB, but now in Slicer 510, you can do independent settings mode, or independent component mode, where for each component index here, 0, 1, and 2, you can independently control the opacity and color transfer functions. And just so you don't have to watch me like play with these plots live, I have another Python snippet here that sets them to something interesting. Here you can see the different components each have a different transfer function. It's something other than RGB. Let me clear that. All right. So the next one I'll show is compositing an arbitrary number of layers. So for a long time, the slice views in 3D Slicer have only supported a foreground and background image layer. However, in clinical research, multimodality analysis is increasingly common, where more than 2 types of images are required for a given specimen. So you really need a way to blend and compose an arbitrary number of image layers. And in Slicer 510, it's now possible to do that programmatically. And so it's something we can do from the Python console. And I'll show an example here. So first, let me show you what I mean by foreground and background compositing that already existed. Let's load CT-MR-Brain. This just loads a few scalar volumes that are all kind of in the same space. If I go to the slice settings, the slice view settings, I have this like background and foreground. So I can set MR Brain T2 to be the background and CT Brain to be the foreground. And then there is a kind of blending of the two. But all you have is these two and then a label map layer. You cannot blend arbitrary number of layers until now. So now what I have is a Python snippet that I'll copy here that does the following. It loads 3 MR heads and then gives them different color maps to make them look interesting and different from each other. and then translates them around so that you can see the differences, and then it sets up a blending. And the key is the use of the composite node. So we're grabbing the composite node from the slice widget and then setting volumes to be in different layers. And here we're doing 3, but you could do an arbitrary number of them. So let me just copy this and paste it. And here you can see three blended scalar volumes. And in this particular case, we're setting it to do add blending. You could also do alpha blending, reverse alpha, or subtract. Those are different blending modes. Let me clear my scene. All right, so that's it for core features that I'm demoing here. Now on to a select few extensions of the many that have been added. So I just chose a few to showcase here. The first one is slicer tram. So one question that gets asked more and more often by product developers who are using Slicer is, can I get such and such Slicer functionality running in a web browser? Can I deliver it to my customers in a web application form? And so there are a few answers to this question, and Slicer Tram is one of them. So Tram in general is not connected just to Slicer. It's its own thing. It's a Python framework for building web applications, and it's commonly used to turn Python-based scientific visualizations into web apps. And then with Tram Slicer specifically, you can make core Slicer functionality available to a Tram web app. So this is a Python library, Tram Slicer, which is used to create modern view-based web applications using the Tram framework. So when you're using Tram Slicer, you don't actually need Slicer itself to serve as your backend, because there are some limited Python wheels that are provided to kind of provide the VTK murmel scene functionality to your Python Tram application. However, if you want to go beyond those limited wheels, you could use Slicer as sort of your backend, as the thing that provides the Slicer Python environment to your Tram application. And the way to do this is using the Slicer Tram extension. So I'm just quickly going to show, I have that extension installed here, and I'm going to quickly show an example of it. So this is the Slicer Tram server module, and it's currently set to run a particular Tram Slicer example application, which is this medical viewer app.py. This is an example application that comes with Tram Slicer. So you would be like writing your own applications. So I'll start the server, and then it'll run the server locally. It's using Slicer to provide Slicer's Python environment. And then it just opened this browser. I'm at localhost 8010 here. I can open an MR head, scroll through it. I can have segmentations, markups. We can make a line here. And this is all in a web browser inside the medical viewer example application. And none of this stuff is happening inside Slicer. They're not synced up or anything. This is its own application. Slicer is just providing the VTK murmel core logic to this Tram application.
Hey, Ebrahim, another question came in. Can you talk about the asking the advantage and disadvantage of the Tram Slicer way of porting applications to the web versus running the whole 3D slicer within like a cloud infrastructure like AWS upstream?
Yeah, this is a great question. So if you app stream Slicer, that actually has been found to work very well, but it doesn't provide you with a web native experience. So you're streaming, you're still streaming a desktop application. But the example medical viewer application that you just saw that comes with Tram Slicer, that was a Vue web application. So the entire graphical user interface was truly something that was running in the browser. It would behave very responsively, and you have kind of web developer level of customization for things. So those are both like excellent ways to get Slicer in the web, the AppStream approach, the Tram Slicer approach. There are some others. It just depends on kind of how much work you want to do developing on an entire front end, and how important it is to you to have highly customized web native interface.
All right. Thank you.
The next one I'll show is CAD's whole body CT seg, which is part of the CADS group. So this adds to Slicer's repertoire of AI-based segmentation tools, of which there are a few, quite a few now. And it is an automatic CT segmentation tool, kind of like Total Segmentator, and adding just additional capabilities, more structures, and it has some additional performance on outlier cases. So if you want to set up CADS, so this is the module. If you want to set it up, it will install all the Python requirements for you, with the exception of NNUnet, for which you need to go to the NNUnet module, go here, and then type in the exact version that it wants, and then hit install. And if you do that, you should be all set to use CADS. Even without a GPU, it can run on CPU. It's just slower. So yeah, let me go grab sample data. Let's say the CT liver. And let's go to CADS. And you can see you have different choices of segmentation tasks, core organs, spine, heart and vessels. Let's say I pick head and neck, then I can select targets here, which targets I want to include, or I can say all targets. And then you just hit apply and it creates a segmentation. So I already did this offline with the settings core organs and all targets and with CT liver. So let me just load that in. And we get a nice segmentation like this. It might look nicer if I show the volume as well with it. Yeah. So that's CADS. Then I'll show OpenLIFU. So Slicer 510 includes now OpenWater's focused ultrasound research platform, OpenLIFU. So this can be used alongside OpenWater's wearable ultrasound transducer hardware to do neuromodulation work, from treatment planning to sonication. So I'll just show an example of this. Let me clear my scene. So I have downloaded some of the example data that OpenWater makes available. And I'll load an example session. Just to show what it looks like. So here you see subject patient MRI. You see the slices of it and a skin surface that was extracted from the MRI. And you see a transducer device. There's a kind of device model, but it's also aware of kind of the phased array of transducer elements that are inside there. And it provides a workflow. So you have kind of this pre-planning module where you can set a sonication target and then run an auto-fitting algorithm that tells you where to put the device so that the beam can be steered to the target. And you have an entire workflow here with a number of modules. So other modules include device localization during a treatment session to figure out where it actually is in MRI space. You can do ultrasound simulation. You saw it knows where the transducer elements are. And there's a module to actually control the hardware. So that's OpenLIFU. And then finally, I'll show modality converter. So this is an extension that provides generative models for medical image-to-image translation, like MRI to CT or cone beam CT to CT. And for example, you could use this to generate synthetic CT images from MRI images for radiation therapy planning. Really, anytime you have a workflow that needs to start from a CT image, if you are able to convert whatever image you have to what a CT would have looked like, then this sort of lets you plug things into that workflow from other modalities. So let's just see what it looks like. Let me restart the slicer. So actually, let's load an MR head. So here's modality converter. It's got a nifty little guide here, and it lets you choose an input volume. It will handle installing the Python dependencies for you. I've already done it, and so my run button is green here. And you basically select a model and run it. So I've got it set to CT to MRI to CT. And you can also add your own models. There's a link here for how to do that. And I've also already run this. So here's the outcome. Here's our favorite MR head as a CT scan. So that's modality converter. And with that, we'll switch back to Sam.
Alrighty, so we'll kind of look briefly at some of the features that aren't quite as demoable, and give a quick overview before handing things back to Andinet. So kind of the once again, we discussed previously that the Slicer's Python environment has been upgraded from 3.9 to 3.12. This has been a significant infrastructure effort by the community, and encapsulates 3 years of Python improvements. And by going through the 3.10 version, some massive changes in how the Python environment is built and managed. So that's new language features, improved traceback readability, performance improvements, and most critically, access to modern packages. Because as our kind of medium and advanced users often want to install their own Python packages for their own processing pipelines into 3D Slicer, and we were encountering a situation where the 3.9 packages were starting to come out of support and no longer be available. And so with the kind of big change getting through the 3.10 updates, we should be able to keep the Slicer version, the Python versions within Slicer, more modern as we go forward. And as previously discussed, the DICOM TLS support, which improves the DICOM PACS interface within encrypted hospital contexts. So this is very good for application developers who want to deploy within an encrypted PACS system. So looking forward to Slicer 6.0. The big thing that we want for Slicer 6 is Qt6. Qt is the GUI rendering library that we use to to support the slicer application, and Qt6 is the latest version, and support has now, as of I think 2 days ago, been merged into the main branch. So the development team is testing those updates so that we can eventually get Qt6 turned on for the nightly builds, so that the nightly previews that you download will be using the latest open source versions of Qt. And Qt 6.7 will be the minimum supported Qt version. And this work has required significant updates to CTK and Python Qt to support the Qt6 transition. So the Qt6 transition is important because it is necessary to keep Slicer building with modern compilers, since Qt is such a big part of the build system. And so this is a dependency that we need to keep updated on so that we can have the latest and greatest Qt features and keep the entire, and kind of reduce the amount of technical debt throughout the entire build system. So things coming for Slicer 6, as mentioned before, Qt6 will be enabled. This will, Qt6 will help us move to ARM64 build support, i.e. native binaries for Apple Silicon. For our macOS support right now, we are still building the Intel x86 binaries, which then run on the Apple Silicon machines using the Rosetta 2 interface. And that has actually worked quite well for us, so we've been able to avoid having to dip our toes into building on Apple Silicon while things are still experimental. But with the Qt6 transition, that's going to greatly simplify the work that we need to do to support ARM64 machines. And will be, in the near future, be distributing 2 binaries for macOS, one for Intel-based systems and one for the Apple Silicon. We're also looking at improving development environments for our ever-expanding community development team, making it easier to jump into developing with 3D Slicer without having to fully manage and spin up the development environment on your own system. New features that are coming along are the improved visual DICOM browser, which should kind of modernizing the interface of the current DICOM browser, and improved extension dependency management, so we can manage Python packages that are installed by extensions to reduce the likelihood of version mismatches and crashes, and we can better support more complicated interactions between extensions. Whereas one extension requires, a reader, some support from another extension, it can better express that to the software and then give better feedback to the user about how they need to set up their Slicer environment. All right, and so now we're going on to pool question 3, which is what would you like to see in Slicer 6.0? So the options we have here are enhanced AI-based segmentation tools, improved DICOM support and workflows, faster rendering performance, more intuitive UI UX updates, and additional extension modules and integrations. If you would, please take a moment to respond to the poll. And we do take this feedback very seriously. Slicer has always been a community-driven project, and your input helps shape our roadmap. The development team actively looks at what users are asking for in webinars like this, on our GitHub repos, and on our discourse forum, so we can best figure out what the community needs, because that's the best way to focus our energies as we are allocating development resources. If you have more detailed suggestions or feature requests, I encourage you to post them on the Slicer discourse. All right, looking at the results for the polls, it looks like the top is 77%. Of course, the enhanced AI-based segmentation tools, which has been a very popular feature, and we've been putting a lot of work on pushing Slicer forward on that. Next is more intuitive UI UX updates. That's definitely something that we are looking to do, modernizing the the current Qt interface to something that fits better with the kind of scientific computing ecosystem. Down from that, faster rendering performance at 47%, 37% additional extension modules, and 23% say improved DICOM support and workflows. Alrighty. I guess we'll hand off to you, Andinet.
Excellent. All right. Thank you, Sam, and thank you, Ebrahim. That was great. I'll ask everyone to please add your questions to the Q&A. So we'll make sure we get to them. So I just want to quickly go over some of the product offerings we have at Kitware. Obviously, Kitware is open source and free, and anyone would be able to use it and develop applications. But in some cases, if you need help in code development, maintenance, we do have now 3 product offerings. The first one is maintenance. In some cases, organizations that need to ensure Slicer keeps working reliably for their workflows, we offer basic and enhanced packages, which includes helping you fix issues that come up, doing some optimization, improvement, and also guidance on product development. The second one is training. We do have now about 4 different courses around 3D Slicer for basic training, advanced training, DICOM fundamentals, and then also how you can use Slicer for IGT, image-guided surgery. And obviously, the third one is on custom development. If you have a need for a proprietary customization of 3D Slicer, or even a clinical research prototype, Kitware will be able to provide help. You can find more details at the links that you see below. All right. With that, I think we will open it. We'll have the last poll question, and then we'll open it up for Q&A. We just want to make sure these webinars are useful to the community, and we will start planning for the next webinar. So we'd like to get your input on this. So the poll question here is, what type of content would you like to see in the next webinar? So we've given you 5 choices here. So if you can take a moment to respond. Live demonstrations, I think Ebrahim did a really good job today. If you'd like to see more of that, deep dive in some of the new features, or are you more interested in some beginner's tutorial? We could also do a webinar around advanced scripting. How can you script some new features in 3D Slicer? And then case studies for real-world applications. All right, so the responses, we see the majority interested in advanced scripting Python and also case studies for real-world applications. So we'll take this into consideration when we plan our next webinar. Okay, all right. So next, we'll just open it up for Q&A. If anyone has any questions, please put it on the Q&A tab, please. So one question came in, and this is for you, Ebrahim, about the open water module. The question is that it's a module freely available that anybody can use it, and how customizable it is?
Yes, it's open source, freely available. It has a copyleft license, so that's something to be aware of, at least at the moment. And yeah, it's freely available. It is meant to be used with OpenWater's transducer hardware, so it's kind of the accompanying software to go with that. But the hardware itself is also open source.
Okay, thank you. A question for you, Sam. If people want to be involved in the community, contributing bug fixes and PRs, asking what would be the right way to do this?
So the first steps to getting involved in the community or kind of checking out the GitHub repo. And I know that we have some issues on the GitHub repo tagged as good first issue or good things to tackle for newer developers. Also, just we have a weekly meeting on Tuesdays that we announce on the discourse forums, which is the Slicer developer meeting. That's kind of the best way to just get yourself introduced to the development process. And if it seems a little daunting to just pick an issue out of the tracker, you can show up to the meeting, kind of get to know everyone, and kind of ask for some guidance on where people think you should start based on your experience and what you're interested in doing on some good initial topics and some things to work on. So we're always looking for new contributors, and we encourage everyone who's interested in contributing to join the developer meeting and get involved on the discourse forum to get to know everyone.
Great. Thank you, Sam. All right, so just want to remind everyone that we'll be sending a follow-up survey about this webinar. So we would love to have you, take a look at it. It shouldn't take too long and respond to that. And those type of responses and feedback will help us in planning future webinars. And also, we'll be sending out a recording of a video of this webinar and also the slides that we showed today. So feel free to share that with your colleagues, your friends, and then also if you have any follow-up question, feel free to reach out to us at kitware.com. We do have a contact form where you'll be able to reach us out. All right. With that, we thank everyone for joining us today, and we look forward to seeing you in our next webinar. Thank you.